Okay, so now it's time for ion formation for the group A elements. This is from chapter 3, pages 51 through 54, and exercises 3E and 3F. We've talked about this in class, but let's go through a brief review. Remember, the group A elements have predictable ions, whereas the transition elements have variable ions, and you can't just look at them and tell. So, when we look at the periodic table here, these are the group A elements. They have A's above each of their columns. Down here, all the ones that have B's, these are the transition metals, and they have variable charges. For instance, lots of these elements here can make +2, +3, +4, +5, +6, +1, different kinds of charges, and you can't tell just by looking. But you can tell by looking at the group A elements, so we'll be focusing on those. Alright? A couple other things to remember. The octet rule rules. The group A elements will form extra stable ions. All atoms have a certain stability to them because the number of protons and the number of electrons are the same, but you can get extra stability by adding or losing electrons. Adding electrons making negative anions, losing electrons to make positive cations, and the reason why you would add or lose to get that extra stability of having 0 electrons or 8 electrons in their outer shells. We'll talk more about shells in Chem 15. You just want to concentrate on 0 or 8. Now that first row is a little different, because in the first row we only have 2 elements, hydrogen and helium, so satisfaction for those two, extra stability, occurs with either 0 or 2 electrons. But for the rest, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. If we skip this middle part, we still are going to count 1, 2, 3, 4, 5, 6, 7, 8. That's where the 0 or 8 comes into play. Okay? What else do we have to worry about here? Whatever's easiest to get to 0 or 8 is the ion that will actually form. It doesn't matter. It's just as easy to gain or lose electrons. The idea is getting to 0 or 8. Okay, so let's go with an example question. What ions will the following elements form? The element that we're talking about is element K. That's potassium. And there's potassium right there. Okay, so you want to look at the column the potassium is in, and it's obvious in 1. So we have a decision tree that we go through for each of these. I'd like you to make sure you have this and say it over and over again every single time. And it goes like this. How many electrons are in the atom's outer shell? And that's the same as the group number. So because K is in group 1A, the answer to number 1 is 1 electron in the outer shell. Okay, the next question always is, how many electrons does it want? And unless we're talking about hydrogen or helium, the answer is always 0 or 8 for every group A element. The third question, how many electrons need to be added or lost to get to 0 or 8? Okay, so let's take a look at that. You have 1 to get to 0. You could either lose 1 electron, or to get to 8, what would you have to do? You'd have to gain 7 electrons. What's easiest? To lose 1 or gain 7? Clearly, it's to lose 1. And so, what's the ion charge that forms? Well, if you lose 1 electron, that means you've gotten less negative or more positive, so you're going to form a +1, and the formula goes K plus 1. That's how we write the ion charge. Okay? That's it. How many electrons are in the outer shell, which is the same as the group number? How many does it want, 0 or 8? How many do you have to add or lose to get to 0 or 8? And what's the charge on the ion that forms? That's our method. We do it over and over and over again. So, what I'd like you to do, let's see if I get them all in there. Okay. So, hit pause. After writing these elements down, go through your decision tree, figure out the number of ions that form, and then see if you've got the same formula as me. You ready? Hit pause. Okay, you're back. This actually, if you know what you're doing, goes real fast. Sulfur is in group 6A. Therefore, 6 electrons in the outer shell. Right? How many does it want? Well, everything wants 0 or 8. If you have 6 and you want to get to 0, what would you have to do? You'd have to lose 6 electrons. If you have 6 and you want to get to 8, what would you have to do? Gain 2 electrons. What's easier, losing 6 or gaining 2? Easier to gain 2. If you gain 2 electrons, you get more negative by 2. So sulfur is going to make a -2 anion. Calcium. Calcium is in group 2A. Therefore, 2 electrons in the outer shell. Wants? Everybody wants 0 or 8, unless you're in the first row. To get to 0, if you start with 2, you just want to lose 2. To get to 8, if you start with 2, you want to gain 6. Easier to lose 2. If you lose 2 electrons, you get more positive by 2. Calcium is going to make a +2 cation. Bromine, 7A, which means 7 electrons in the outer shell for the neutral atom. But you can get even more stable if you can get to 0 or 8. See how fast this goes? All you got to do to get to 0 is lose all 7 electrons. All you need to do to get to 8 is gain 1 electron. What's easier? Clearly, easier to gain just 1. If you get more negative by 1, you're going to make a -1 anion. Don't memorize. Go through the decision tree. It's too easy. Aluminum is in group 3A. So how many electrons are in its outer shell? 3 electrons. Everybody wants 0 or 8. If you start with 3, to get to 0, you'd lose 3 electrons. Or, to get to 8, you'd have to gain 5. What's easier? Losing 3. That means you get less negative or more positive by 3. Nitrogen, 5A. Make sure you can easily tell by going to the periodic table and finding those. Okay, 5 electrons in outer shell. Therefore, to get to 0, you'd have to lose all 5. To get to 8, you'd have to gain 3. It's much easier to gain 3 than to lose 5. So we're going to gain 3. Nitrogen gets 3 extra -1s, 3 extra electrons. There's the charge. Carbon. Carbon is in group 4A. 4 electrons. It wants 0 or 8. Okay? To get to 0, you'd lose 4. To get to 8, you'd gain 4. There's no advantage either way, which means it could make either ion. It could make a carbon plus 4 or a carbon minus 4. It all depends on what it's reacting with. Okay, one last example. Helium. Helium is in group, well, what is it in group? It's in the last group. So it actually has 2 electrons in the outer shell. It's a little confusing, but helium is atomic number 2, so it has to have 2 electrons because it has to have 2 protons. Since it's in that last row, it wants 0 or 2. To get to 0, you'd have to lose 2 electrons. To get to 2, you'd do nothing. So what do you think is easier? The answer is nothing. And helium makes no ions because it's already stable. It's already got its 2 electrons in its outer shell and it's happy. All those elements on the end are called the noble gases or the inert gases because they already have full outer shells and they're happy and they don't like to make ions. Okay, this is a really important skill. Practice up, make sure you're good at it.